Hello students, in the previous lectures we have seen about Poisson's equation and Laplace equation, and also we have derived the Poisson's equation and Laplace equation, and we have seen the equations of Laplace in all the coordinate system, that is Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. Okay, now actually I have told about Poisson's and Laplace equation, why those are used, because to evaluate the boundary value problems. So hence some more applications of Laplace and Poisson's equations need to be studied. That is the applications of Laplace and Poisson's equation we can see now here. So what are the applications of Laplace and Poisson's equation? So using Laplace and Poisson's equation, what we can do is we can obtain the potential at any point in between two surfaces when potential at two surfaces are given. That is meaning is we can obtain the potential at any point in between the two surfaces when the potential at two surfaces are given. So this is the first application. Now second application of both is we can also obtain the capacitance between these two surfaces. Means if two surfaces are available, we can obtain the capacitance between both the surfaces. So that is the application of what Poisson's and Laplace equations. Right now as we have find out the Laplace equations for all the coordinate systems, so let us see one problem to satisfy the Laplace equation in Cartesian coordinate system. So that is what, whether the Laplace equation is satisfied or not, we can go through one of the example. Right, so next we just go through one of the example. So take this example. So let v is equal to 2x y cube z cube and epsilon is equal to epsilon naught full point, given point P into bracket 1 comma minus 1 comma 3 comma minus 1 bracket complete. Find potential at point P and also find that V satisfies the Laplace equation. This is what the problem statement, where we want to find out V, and also we have to check that whether V is going to satisfy the Laplace equation or not. So solution for this is, take the equation V is equal to 2x y cube z cube, where V at the point is evaluated, that is nothing but 1 comma 3 comma minus 1 bracket complete. We can find out V, put the value of this x y z in those equation. So that is nothing but 2 into 1 into 3 cube 3 square minus 1 cube, right? So that is what, after putting it, we get the value of potential, that is minus 18 volt. Right, as the equation is given in terms of Cartesian system, so we have to consider the Laplace equation in terms of Cartesian, that is del square V is equal to dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square is equal to 0. So to evaluate this, to satisfy the Laplace equation, first we have to differentiate given V. So let us consider first order differential equation, that is dou V by dou x is nothing but what of that equation is 2y square z cube, and if you want to again differentiate, it becomes dou square V by dou x square is equal to 0. So totally dou square V by dou x square becomes 0. Similarly we have to evaluate for dou square V by dou y square and dou square V by dou z square. So let us see that. So first differentiation is dou V by dou y, that is nothing but we get as a 4x y z cube, and if you differentiate again we get what, dou square v by dou y square is nothing but 4x z cube. So this is the equation for in terms of y. Now similarly we have to differentiate for in terms of z axis. So dou v by dou z, first differentiation, 6xy square z cube it is, that is nothing but, one more times you have to differentiate, dou square v by dou z square, that is equal to 12xy square z. So adding all these double differentiating terms, so to satisfy the Laplace equation, because Laplace equation already you are knowing this, what is in the previous scene, you are seen that dou square v by dou x plus square plus dou square v by dou y square plus dou square v by dou z square should be equal to 0. So you put all these values whatever you obtain. So there is nothing but first value is 0 plus 4z square plus 12xy square z. So this addition does not make the equation 0, so which is not equal to 0. Hence, thus what we tell is the given v, whatever it is we get in the example, it is what is happening is it is not going to satisfy the Laplace equation, right? So they have asked whether it is satisfying the Laplace equation or not. So by determining the Laplace equation, we tell that it is not going to satisfy the Laplace equation. Means when it is not going to satisfy, when it is not, it becomes not equal to 0, then only it is not going to satisfy the Laplace equation, right? So this is about one of the example of Laplace equation and the applications of Laplace and Poisson's equation. Thank you.